Welcome to Session 4 of the current solar panel program. In this session, you will be learning the basics of C++ through the Arduino IDE. In addition, you will test your device at the end of the session. To begin learning about the C++ language, you first need to know about variable declaration and expressions. Variable declaration is when a word or identifier is declared as a variable with a value and a data type. When creating a variable, we set its type, followed by the variable name, and then we set it equal to a value if we want to, though it is not required. There are a few data types you should get familiar with. These are int, float, string, and char. When declaring a variable, we should use one of these types depending on what information the variable will store. We use string to represent words and sentences, and we use char to store a single letter. The int type stores an integer value, and the float type stores a decimal number. We can use these variables in expressions such as the one shown here. What do you think this outputs? You might say 5.5, but it will actually output just 5. In this expression, we worked with strictly integers, so the output must be an integer as well. In general, when an expression uses only integers and the result should be a float, the output just has its fractional part cut off. Now take a moment to think about what the second line outputs. Should be 3, right? It is, but remember that there is at least one float in the expression, so the output must be a float as well, hence the decimal point after the 3. You are now going to start a short activity based on what you learned so far. You should be familiar with the format of the code in the IDE, but here are some lines you will need to know. The first line starts the transferring of data from the Arduino to your computer. The number inside is the baud rate, which is how many bits of information can be sent per second. This line should be placed in the setup function. The next two lines are ways of sending data to the computer. The objective of this activity is to create string variables to store your name, hometown, and favorite food. Then, create int values for your age and graduation year. Take these variables and serial print them to the computer. Also, add a delay of 2000 milliseconds, so the variables will print every 2 seconds. The activities in this session will not be directly demonstrated, but the solution code to all activities can be found on our website, in the sample code folder. If, and else statements are an important aspect of coding. They work by running the code inside the brackets if their conditional statement is true. In this example, code number 2 is run because the variable num is equal to 10, and the only statement that is true is the second one. Now take a moment to look over the second group of code and decide which code will run. The answer is code number 3, because num is neither greater than or less than 10. Now take a moment and figure out what happens in this last group of code. The answer is nothing happens, because the only conditional statement is whether num is greater than or equal to 11, which is not true. Your next activity is to develop some code that will ask the user to input a letter, then prints the day of the week corresponding to that letter. For example, if you input T, the word Tuesday should print out. The code that is shown allows the user to input data and store it in the input variable. Then check this letter and output the corresponding day of the week. Note that after you compile and run your code, there is a section at the top of the serial monitor window that will allow you to input letters to the Arduino. For loops and while loops can be thought of as repetitive if statements, meaning they continue running as long as the conditional statement is true. If you look at the code above, the first line is how you format a for loop, and everything inside the brackets is the code that will continue to run. As you can see, the for loop first creates an int variable called num and sets it to 0. It then checks if num is less than 10, and if it is, it will run the code inside the loop and then add 1 to the num variable. Take a moment to decide what the code will print out. The code will print out the numbers 0 through 9, as shown here. The code and circuit shown here shows how to control an LED with the Arduino. This code will probably be familiar to you, as you use similar code in session 2. The line inside the setup function here tells the Arduino we will be using pin 10 as an output. We then use the digital write function to tell the Arduino to send a given voltage to a given pin. High means 5 volts and low means 0 volts. This last activity is a bit challenging. Look at this video to see how the LEDs should behave with the program you write. They should turn on and off one after another. Try to use a for loop that goes through each of the pin numbers. Here is the wiring diagram for this activity. Take note of what pin numbers your LEDs are connected to so that you can use those pin numbers in your program. In this last activity, we will be testing the current sensor and the solar panel combination. You have already built this circuit in session 3. Open the Arduino serial code file, and we will take a look at it to see what everything does. Take a moment to understand it. Essentially, this code will take the voltage and current readings from the current sensor, calculate the power generated by the solar panel, and then print it to the serial terminal. You can easily tell if the circuit you built is correct based on the output you see from your code. You should see positive power readings that change if you change the amount of light hitting your solar panel. If you see negative power readings, you should check your wiring. Alright, so here I'm going to be demonstrating activity 4.4. Now this activity is just for measuring our solar panel system that we've just built and making sure that we can get current, voltage, and power readings from it. So for this, all you're going to need is your solar panel system from the last session, a Arduino connector cable for USB, and a laptop so we can see serial output. Now let's get started. Alright, so the first thing we're going to do here is we're going to take our device out of the box a little bit so we can access it. We're going to unplug the battery, and we're going to plug in our laptop using the USB cable. So now we plug that in. Now on our laptop, we're going to open the Arduino serial code file, which you can find on our website, and we're going to upload it to our Arduino. So I'm going to make sure that we have the right port selected, and then click the upload button. And once that's finished uploading, we should be able to run it, and we can see the output we're getting. Alright, so as you can see, we were getting somewhat low power readings. So now in order to make sure that we've hooked up everything correctly, we're going to shine our flashlight onto the solar panel, and we should see an increase in the power readings. So I'm going to go ahead and do that now. Shine my flashlight, and we'll see an increase in the power that we're getting. This concludes session 4 of the current solar panel program, and I leave you with this quote: "Nothing in life is to be feared, it is only to be understood. Now is the time to understand more so that we may fear less."